So today we're talking about velocity. Now this is going to be another one of those lessons for those of you who are in physics that you're going to need to do it the math way as opposed to the physics way. I know you probably know another way and it's another easier way to do it, but for right now, bear with me. We will do it an easier way in a little bit, and I think that's probably the way that you learned it in physics, but not positive. But we will get to that in a little bit, maybe tomorrow or the next day, but just not quite yet. So bear with me and try it the way that I'm showing you. I know you don't like it, but then suck up and deal. So average velocity. In an average velocity, I'm going to be using 2 points, and they're going to give me a particular point A and a particular point B. So usually like time 1 and time 2 or something like that. And that would be my A and my B. So basically to find the average velocity, I'm going to find the change in distance over the change in time. If you notice, f of B minus f of A over B minus A should look kind of familiar to you because it is the slope formula. So basically you're just using the slope formula in order to find the average velocity. So here's my problem. I'm given a physics experiment. I have the height of a ball and they give me an equation where t is the time in seconds and the height of the ball is measured in feet. I want to know what was the average velocity between time 1 and time 2. So the first thing in order to figure out, I'm going to use that formula for average velocity, which means I need to know the distance that it traveled, so like the y value or the h of t, if I plug in time 1 and time 2. So that's the first thing I'm going to do, is I'm going to plug in time 1 and time 2. So at time 1, notice that my height is going to be 94 feet. If I plug in a 2 into that same equation for my height, I am going to find that my height is 141 feet. Now I'm just going to use the formula for average velocity, which is my slope. So I'm going to take f of b, which was 141, minus f of a, which was 94, over b minus a, which was 2 minus 1. So that means my average velocity, or the slope between those 2 points, is 47 feet per second because we were measuring it in feet and the time was in seconds. So pretty easy, not too difficult. Now we're also going to talk about instantaneous velocity. Instantaneous velocity is the same basic idea, except obviously it's at a very instant in time as opposed to between 2 points. So in order to find the instantaneous velocity, I'm going to take the limit of f of t plus h minus f of t over h, which again should look familiar to you because that's the limit formula that we've been using all along. And of course, it only works if the limit exists. So here's my problem. Tourists are standing on a 300-foot tower, and they also often drop coins into the fountain below. Don't do that, that's rude. But anyways, the height of a coin falling from the tower after t seconds is given by h of t, which is 300 minus 16t squared. I want to find the instantaneous velocity of the coin at 2 seconds. So how fast was the coin falling at 2 seconds? So therefore, I'm going to use the formula. So here's my formula. I'm going to have my f of t plus h minus f of t. So I'm going to substitute in I forget now what we were doing. Oh, 2 seconds. I'm going to substitute 2 seconds in for t. So therefore, I would have my equation, which remember we said was 300 minus 16t squared. So I'm going to have 300 minus 16 instead of t. I'm going to have 2 plus h because my time that I'm interested in is 2 plus h minus the f of t, which was 300 minus 16 times 2 squared. I'm going to substitute that all out. And when I substitute that all out, I'm going to end up with my limit. And my limit is going to be simplified the same way that I've been simplifying them all along. And then on the next page, we're going to cross out our h's. And I hit the wrong one, so let's try that one. And we cross out the h's, and I'm left with the limit of negative 64 minus 16h. Of course, then we're going to remember to take the limit, and when I do that, my limit is negative 64. So that negative 64 just basically tells me, oh, it says that there, indicates that the height of the coin is decreasing, so it's a falling object. It's not telling me that it's a negative amount. It's just telling me the position. So that means that it is falling at 64 feet per second. That particular coin when we drop it at 2 seconds off of the 300-foot tower. So now I have another one. where I have a distance of a bumblebee is given by that particular path. I don't know who measured it, somebody did. Where t is given in seconds and the distance of the bumblebee from its starting point is given in inches. Find the equation of the instantaneous velocity at any point in time. So since it's at any point in time, instead of plugging in a variable, I'm going to be using it with an x. So actually a t, since we're using time, sorry about that. Since we're using a time, we'll use our t variable. So therefore, I'm going to use my instantaneous velocity equation. So I'm going to use my equation, and wherever I see an x, I'm going to substitute in a t plus h. And again, it was a t. Wherever I see a t, I'm going to plug in a t plus h. So I'm going to have 12 times t plus h minus 6 times t plus h cubed plus 1 minus that same f of x. And then I'm going to simplify a whole lot. And when I simplify, I'm going to end up with 12h minus 18t squared h minus 18t h squared over h. And then I'm going to simplify some more. And I'm going to factor out my h's. And then I'm going to remember to take the limit. So when I take the limit, I'm going to substitute a 0 in for h. So I end up with 12 minus 18t squared would give me my velocity of my bumblebee at any time. And then if they ask me, like, what is it at time 2? I could plug in a 2 for t. Or what is it when it's time 5? I could plug in a 5 for t. And that way I can plug in any number they want me to do. So that makes it a little bit easier if I leave it in terms of t. So that's an easy one for today. All we're going to be doing for the next class is basically doing a whole bunch of word problems applying these ideas of finding average and instantaneous velocity. Good night.